Example 3, dimensions of a building lot. A rectangular building lot is 8 feet longer than it is wide and has an area of 2,900 square feet. Find the dimensions of the lot. So here's our rectangular building lot. It is 8 feet longer than it is wide, so it's got some width, and then the length is 8 feet more than that. And we have the total area. We know that since this is a rectangle, the area would just be length times width. So we can write that out. X times x plus 8 equals the area, 2,900. And we can solve this equation. This will tell us the width, and then we'll add 8 to find the length. X times x is x squared plus 8x. In the same step, I'm going to move the 2,900 over so we can solve this quadratic. Since 2,900 is a pretty big number, it could take some time to figure out the factors that would equal 8. I already know that they are 50 and 58, so it'll be x plus a positive, so it's a positive 58 and a negative 50. We have our two factors. Tee it up and solve. X plus 58 equals 0 and x minus 50 equals 0. So x equals negative 58 and x equals 50. Since x was the width, there's no way that it could be a negative. There's no negative lengths. So that means our width is 50, and then our length was just x plus 8, so that's 50 plus 8, should be 58. This is our width and length. And our units were, for area, were feet squared, so this is 50 feet by 58 feet. Example 4, determining the height of a building using similar triangles. A man, 6 feet tall, wishes to find the height of a certain 4-story building. He measures its shadow, the shadow of the building, and finds it to be 28 feet long, while his own shadow is 3.5 feet long. How tall is the building? So we already have a picture drawn out here. Pictures are often helpful. How tall is the building? That's what we're trying to find. So there's the height of the building. I'll call it x. The other dimensions are already labeled. For these, we can just set up similar triangles as the title would suggest. We can do height over shadow. I like to label what we're going to do for proportion so you don't mess up. Height over shadow, and keep it consistent throughout. So if you do height of the building, x, over the length of the shadow of the building, 28, equals the height of the man, 6. It's also important that these are all in the same unit, feet, throughout. Over the length of the shadow of the man would be 3.5. Now it's just a proportion. We can cross multiply, so 3.5 times x equals 28 times 6, 168. Divide by 3.5. we get x equals 48 feet. So the building is 48 feet tall. Example 5, mixtures and concentration. A manufacturer of soft drinks advertises their orange soda as naturally flavored, although it only contains 5% orange juice. A new federal regulation stipulates that to be called natural, a drink must contain at least 10% fruit juice. How much pure orange juice must this manufacturer add to 900 gallons of orange soda to conform to the new regulation? So some basics from that, we know that there's 900 gallons of this soda that we'll say needs to be fixed. It has 5% juice. There is as much regular orange juice as we need, so there's just regular orange juice. It is 100% orange juice, and we can add as much as we need to that, so we'll call that our variable, because it's asking how much must we add. And then there's the new soda, which needs to be 10% juice, and will have a total of 900 gallons plus however much orange juice we add. So from here, we can actually solve this just by writing our equation with how much orange juice is in each part. There's 5% orange juice of this 900 gallons. There's 100% orange juice, so of X gallons. And we need that all together to be 10% of our total drink solution, which is 900 plus X gallons. This is a pretty simple equation. 0.055% of 900 is 45, so all of that 900 gallons actually only has 45 gallons of orange juice in it. Then we have plus X, the 100% orange juice, equals 0.1 times 900, so that would be 90 plus 0.1x. So this is a equation with only one variable, so let's move our number to the right. We'll get 45 over here. When we subtract 45 from 90, we get 45. Move our 0.1 over, so we'll get 0.9x on the left. Divide by 0.9, we get x equals 45 divided by 0.9 is 50. So we need to add 50 gallons of orange juice. Example 6, time needed to do a job. Because of an anticipated heavy rainstorm, the water level in a reservoir must be lowered by 1 foot. Opening spillway A lowers the level by this amount in 4 hours, whereas opening the smaller spillway B does the job in 6 hours. How long will it take to lower the water level by 1 foot if both spillways are opened? So for any job question, you have to look at the actual rates at which each object is doing its job. So spillway A, the rate is how fast it happens. So it can do the 1 foot in 4 hours. So it's 1 over 4 feet per hours. Spillway B can do the same job, 1 foot, but it would take 6 hours. And that's feet per hour. And then we know both of them. We don't know how long it's going to take, but we do know that it's going to do the 1 foot in, we'll say, X hours. So it'll be 1 over X feet per hour. So this is just a fraction problem now. A plus B equals the total, both. Now to solve this, we do need a common denominator, so between 4 and 6 and x, the least common denominator would be 12x. So we're going to multiply everything by 12x. So this becomes 12x over 4, which is 3x, 12x over 6, which is 2x, and then 12x over x is 12. So combine like terms, 5x equals 12, x equals 12 over 5, which is 2 2/5, or 2.4 hours, because x was hours, the time on the bottom. So it'll take 2.4 hours for them to both lower the water level.